All right. So what we're going to learn now is how to calculate the percent composition. We're going to learn to calculate the percent composition of a compound. All right, I'm going to determine the percent composition of a compound. So we just did some compounds. We balanced an equation, right? We had to figure out how to balance the formulas, okay? So let's just pull one of those formulas we just did and find the percent composition. How about ammonium chloride here, okay? It's really simple. Here's ammonium chloride. We're going to determine the percent composition of, so we're going to find the percent composition of ammonium chloride. This is our example problem. So ammonium chloride has an ammonium ion and a chloride ion. We need to balance the formula, make sure we have a balanced formula. Ammonium has a 1 plus charge and chlorine has a 1 negative charge, so that's all we need. That's going to balance it out 1 and 1, correct? Mm-hmm. Okay. So the first place we're going to start for percent composition is calculating the molar mass. Well, golly, you've already done that, haven't you? Golly gee willikers. So this is the atomic mass of nitrogen, and there's one of those in the formula, times 1. Hydrogen's atomic mass is 1.00794, correct, times 4. And that's 4.03176. There's one of those. You've got a whole bunch of empty slots over here. Oh, I say a whole bunch. You've got 3 of them anyway. Add it all up. Okay, and then we're going to round that off because we've got these empty slots, mean these 2 digits here are insignificant. Okay, so the mass of ammonium chloride in 1 mole of ammonium chloride is 53.491 grams. That's the definition of molar mass. Okay. However, it turns out this is the mass in grams of the amount of nitrogen in ammonium chloride, in a mole of ammonium chloride. Okay? In 1 mole of ammonium chloride, this is the mass of the nitrogen. Does that make sense? Before this would have to be 5 or higher to round the 1 up to a 2. Okay. So, listen. This is what you need to understand. Remember, all percentages are parts over whole, right? In 1 mole of ammonium chloride, the part of this mass made up of nitrogen is this right here. Does that make sense? So this happens to be the grams of nitrogen in 1 mole of ammonium chloride. Okay? And this happens to be the mass of hydrogen in 1 mole of ammonium chloride. And this is the mass of chlorine in 1 mole of ammonium chloride. And since percents are parts over wholes, we can take this part divide it by the whole, multiply by 100 to get the percent of nitrogen. And take this part, which is the hydrogen, divide it by the whole, get the percent of hydrogen. And take this part right here, which is the percent of chlorine, divide it by the whole here, multiply by 100, and we get the percent of chlorine. And that's what percent composition is. The percent of each of the elements in 1 mole of that formula. Does that make sense? It is easy. It's super easy. It's a lot of math, but it's simple math. Okay? This is stuff you've been doing since what? 3rd grade maybe? When did you first do percentages?
Kindergarten.
No, you didn't do percentages in kindergarten, did you? Come on. Huh? 1st grade? Oh, my. Okay. Well, let's do it. You can calculate the percent composition then by determining the percent of each of these elements in a mole of this formula. Do it. Do it. Do it. You can do it. Or, you can do it. Wow, how he says it in that movie. Yeah. There you go. Alright, so we're going to take 14.0067 grams of nitrogen. We're going to put it over 53.491 grams of ammonium chloride. So multiply all that by 100. No, but the grams did. And this is where we said that in percentages the units cancel, but the species don't always cancel. This is one case where it doesn't. Okay? So this is going to give us 26. Yep. That's what I have anyway. And then we're going to round it off to 1, 2, 3, 4, 5 digits. 1, 2, 3, 4, 5 digits. And we get 26.185% nitrogen in ammonium chloride. Okay. Ah, that's a really good question. Let's find out. What do you think? Well, if you have all the percents added up, what's it supposed to equal? 100. It is supposed to equal 100, isn't it? Let's check it and see. That's a good way to check your work. I don't know.
I got 100.00.
You asked can. You did say can. This time you said can. You may. All right, we need to round it off to 1, 2, 3, 4, 5 digits. And we get 7.537% of hydrogen in ammonium chloride. Guys, y'all, I know y'all are chatting back there and everything and probably having fun and all, but you know, if you're paying attention up here, the more times you hear this, go over and over it, the more likely it is you're going to get it sinking into your head, and the more likely then that you're going to do well on the test. Okay, when you waste time with extraneous conversations, you're likely to miss the repetition that helps you to get it right on the test, okay, or the homework, or whatever it is, okay? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Wait a minute, I only left 4 digits there, didn't I? I should have a 2 on there, didn't I? Okay, there's a 2 there. I would have lost a point on that one on the test, wouldn't I? Got to double check your work. Be careful of the details. All right? So there's basically three answers in a percent composition. Got that? So, listen, this shouldn't be hard. If you understand the basic concept, this should be pretty easy, right?
Yep.
What? Okay. That's because we rounded. Okay. And you might get slightly more, ever so slightly more than 100 or ever so slightly less than 100. But you're going to get really close to 100%. But the rounding then is where the error comes in. Okay? So if you add all those up, you will get slightly more than 100%.
If you put all the whole numbers, would you get 100 upside on?
Say what? If you left all the digits in there?
Yeah.
Well, even the calculator's rounding off when you get out here at the far end. Okay? And so it's still possible to get 0.000000 and then a 1 or something. If the calculator were getting perfect answers, which it can't, nothing's perfect, then yeah, we'd be able to get a perfect 100%. But that numbers have actual limitations, believe it or not. Okay?